Welcome guys. In this lesson we are just going to continue with Science paper 2 for the 2023 for the internals. So question 3A is about differentiate chemical changes from physical changes. So say in a chemical change, a new substance is formed. So that is the key here, is about forming of a new substance. So say a new substance is formed. Whereas in a physical change, no new substance is formed. Right, we move on to question B. Classify the following processes as either physical or chemical change. So the first one, condensation of steam to water. So here, steam is still water, but in a gaseous state. So here, there is no new substance. We are just looking at the change of state from one state into another state. So this is a physical change. So typically, if you look at chemical change, we are looking at where we have a reaction. And because of that reaction, we produce a product that is new. And the other thing is the product that you get after a chemical change cannot be, or sometimes it's hard to reverse. But for a physical change, the process is reversible. We can change water, which is in a liquid state, back to steam. Now for Roman number 2, rusting of iron. So this is a chemical process, it's a reaction. So this is a chemical change because the substance that will be produced is a new substance. Now what of photosynthesis? Photosynthesis produces new substances such as glucose and oxygen. So this is also a chemical change. Right, we move on to question 4. So under question 4, halogens are diatomic. So if you look at halogens, we are looking at group 7 elements. Then what does the term diatomic mean? So if you look at chlorine has a 2, iodine has a 2, fluorine has a 2. So this 2 is what means diatomic, because di simply means 2. So 2 atoms, we are looking at a molecule consisting of 2 atoms of the same element. So say consisting of 2 atoms of the same element. Right, B, differentiate the bonding in iodine from that in magnesium. So if you look at the iodine diatomic, so the bonding between the 2 atoms of iodine compared with the bonding between the atom of magnesium and oxide. So magnesium is a metal, then the oxide, which is oxygen, is a non-metal. So for this one, we are looking at the ionic bonding, because there is a metal and a non-metal. Then if you look at iodine, we are looking at non-metal, so this is a covalent bonding. So say bonding in iodine involves sharing of electrons, whereas in the magnesium oxide, involves transfer of electrons. So we know that whenever we are dealing with ionic compound or ionic bonding, we are looking at where electrons are being transferred from one element, which is the metal, to another element, which is the non-metal. But for a covalent compound or bonding, we are looking where the stability comes because of the sharing. So two atoms or more atoms, they share a certain number of electrons to attain stability. So that's what you are supposed to answer for a question like this one. Now we move on to question C. Chlorine gas is bubbled through potassium bromide, right? Solution in a test tube until there is no more change. Write the first one, a balanced chemical equation for the reaction. Now first we need to look at the trend in group 7 elements. So if you look at the trend, the first one is fluorine, then the second one is chlorine, the third one is bromine, then we have iodine. Then according to the trend, the reactivity trend of group 7 elements, we are told that as you go up the group, their reactivity increases, which means the element on top is more reactive than the elements below, right? So first, before we now dive into answering the question, we need to ask a question ourselves: will this reaction take place? So the question is, can chlorine displace bromide? Is this possible? So we need to look at the trend. So we can see that chlorine is above bromine, so chlorine is more reactive than bromine, so this reaction is possible. So first, I'm going to begin with the word equation. So the word equation is we have potassium bromide plus chlorine, should be chlorine. So we are going to have potassium chloride plus bromine. Now in chemical symbols, potassium has a valence of 1, bromide has also a valence of 1, so we just put it here. So we're going to have aqueous plus chlorine, so this is a gas, the atomic, remember. So we are going to have potassium chloride, which is KCl aqueous. Now the reason why we are not having subscript on these compounds is because they have the same valences, they are 1 to 1. Then what happens to bromine? So after the bromine is being displaced here, we need to make sure that we put a 2. Whenever you are dealing with group 7 elements, as long as it is an individual element, you are supposed to put a 2, because we are told halogens are the atomic molecule. Then we just have to balance. So for us to balance, we just have to put a 2 in front of KCl and KBr, so that we have 2 potassium is balanced, 2 Br, then 2 chlorine atoms, so our equation is now balanced. Then the other thing, the type of reaction that we are dealing with here is a single displacement. Why is it called a single displacement? Because one single element is displaced by another element which is more reactive than that, right? So now for Roman number 2, we are told to write an ionic equation for the reaction. So in dealing with ionic equation, you break the compound that is in aqueous phase. So the first one, you say potassium has a plus, you put a 2, since we have a 2 in front of potassium bromide aqueous. Then this 2 is affecting potassium at the same time bromine, so I'm going to put Br, so aqueous, plus chlorine is in gaseous state, you just leave it like that. So we go to here, we have potassium plus a 2 aqueous, then 2Cl aqueous, plus the bromine this time is in gaseous state. So this is the we can say overall net equation. Now let's come up with the total net equation. So I'm going to put it here. So we need to cancel the expected ions. So the expected ions are those ions that are in the same state on both sides. So if you look at potassium is in aqueous, also here is in aqueous. Bromine is in aqueous, here it is in gas, so this is not expected. So the remaining is now our net ionic equation. So this is your final answer. Then if you study this kind of ionic equation, can give you the picture about redox reaction, because there is a gaining and losing of electrons between bromine and chlorine, but we're not going to look into that for this video. Now move on to question D. State one observation you would make at the end of the reaction. So the observation is to see if there is a colorless solution. So the solution that we are expected to have is colorless. Now the point is that when this chlorine is added in excess is when you get the colorless solution. But if not, you are expected to have what we call at least a purplish color. We move on to question 5. So under question 5, we have an element in group 1 and period 3 of the periodic table reacts with element N in group 6 and period 2 of the periodic table. Roman number 1, draw a dot and cross diagram to show the bonding in the compound formed between elements M and N. Use the letters M and N and show out the shell electrons only. Now even if we are taught to show the outer shells, first we need to look at the electronic configuration. So we are taught to use M. Now if you look at your periodic table, if you go in group 1, the element that is in group 1 period 3 is sodium, has the valence of 23, here 11. So according to electron configuration, first shell will occupy 2 electrons. So if we subtract 2 from 11, we have 9. The second shell will have 8. The outermost shell will have 1 electron, which is the number of electrons in the outermost shell determines the group in which an element is found. So this one is achieved. Then the number of shells determines the period. So we have shell 1, shell 2, shell 3. So this one is also achieved. We are done with this one. Let's go to N. So we are told N is in group 6, okay? It is in group 6, period 2. So group 6, period 2 is oxygen, but we're not going to use O since we are told to use M and N. So has a mass number of 16, the atomic number of 8, which the configuration will be first shell is 2, 8 minus 2 is 6. Now you need to make sure that if these numbers are added together, you need to get this number. Same applies if you add 2 plus 8 plus 1 must add up to this number. So if you look at the nature of element N, it is a nonmetal. So if this is a nonmetal, it is going to gain electron to become stable. Then what of element M? This is a metal. For this one to be stable, it should lose. Now if you look at element N, for element N to be stable, it needs 2 extra electrons, but one atom of M can only lose 1. So what happens if the number of electrons does not equal, given out does not equal the number of electrons acquired. So in this case, sodium, which is element M, must score another sodium so that they lose the 2 electrons to give the oxygen. What do I mean by that? We can now bring in the valences. So M has the valence of 1, N has the valence of 2. So if we use the cross method, this will give us M2 N1, which is, this is our formula, which simply means that we need 2 atoms of M to give 2 electrons to be acquired by N. Now let's show this by diagrammatical. So since we had only taught to show outer shell electrons only, I'm going to put, this is my M. Remember, the outer shell of M has only 1 electron, so I put 1 electron. Another M will have 1 electron. Then the N, we are told we are going to have 6 electrons in the outermost shell. So that now the 2 electrons will be transferred to this element, which is now the final answer will be M. So the outermost shell now is empty because the electrons have been given out. Now for N, we are going to have the 6 electrons that it had before the gaining plus the 2 electrons that it gained. So N is stable, even these 2 are stable. Now N attains the bit by gaining, so we need to put a -2. So whenever you see a minus, simply means it gained. Then M, the total charge will be plus. This one gave a 1, then this one also gave a 1. So that's what we are supposed to do. Then for Roman number 2, what type of bonding exists in the compound? So this is ionic bonding. Why? Because there is a transfer of electrons. Roman number 3, if the compound formed is soluble in water, describe what would you do to show whether it is acidic or basic. Your answer should include expected result. Right, so to show that this substance is, let's say, basic or acidic, first we need to look at the nature of a metal with a non-metal like oxygen, so which is sodium oxide. So this is a basic. It is a basic, and if you look at the type of oxide, it's a basic oxide. So if this dissolves in water, we will now produce the basic oxide, which is now the sodium hydroxide. So we'll say if sodium oxide is dissolved in water, sodium hydroxide will be produced. So that is the key. So the key is sodium hydroxide, which is a base, will be produced. Now if you look at sodium oxide, which is the compound that we are dealing with, this is a metal oxide. And since it's a metal oxide, if you look at the nature of group 1, this is an alkali. So that is what we are expected to have here. So that's it for this video. Thanks for watching.